Howdy, howdy, everyone. My name is Moonman, and today we're going to be talking about server meshing and network architecture in Ashes of Creation. The most recent live stream went over this specifically, but I wanted to make a video talking through all the systems in simpler terms. A lot of this was very tech heavy, and if you're not a computer engineer or a software engineer, it may have gone over your head a little bit. In this video, I'm going to give you the building blocks to understand the nuance behind the next gen, absolutely stunning, insanely amazing systems that go into the network architecture in Ashes of Creation. In other words, all the systems that make the game run enable us as players to connect to the world, interact with other players, and how the team will deliver a seamless online playing experience for all of us. I will say I'm not a computer engineer, but I've worked heavily with them in my career and have spent time working on software product development, so I have a good baseline understanding. We're going to start with server meshing, dive into microservices, then their innovative approach to the dynamic gridding, replication, and relevancy checks processes. Those terms mean nothing to you right now, don't worry, because I'm going to give you all the knowledge you need to understand what they are, how they work, and how Ashes is taking a completely new approach to all of them. So, server meshing. What is it and how does it work in Ashes? I think we're all familiar with the idea that we connect to a server when we log into an MMO, but I'd imagine most of us are not as familiar with what that means from a technological standpoint. To understand what server meshing is, we need to get a baseline level of understanding of what is actually happening when we connect to a server, as well as how that applies to the world we connect to, or the world that exists in the game we are connecting to. In its simplest form, your computer runs the game client and you connect to a server when you launch that game and get online to play that game. A server itself is basically the thing that is hosting your game and making it available to play online. Basically, we need a computer to be a central point of connection for all players, and that is what a server is. The server itself is not only what you connect to so you can play with other people, but is also responsible for passing and sharing information from player to player. The information being passed in Ashes of Creation includes individual player movement and location, so where you are and what you're doing as an individual, world events, which could be cutting down a tree, NPC actions like spawns, movement, and so on, or even changes to the world as a result of node progression and story arcs. There's more information being passed, but you can imagine all the dynamic world information that exists in an MMO, and that is being logged and disseminated to all players that exist within the world. To reiterate, the server is taking in player information, logging it, and then passing it along to all players so that everyone has a single source of truth and can see real-time changes that take place in the world. As you can imagine, that's a lot of information. That needs to be stored and shared across what would be thousands or tens of thousands of players simultaneously. Trying to get a single server or a single computer to pass this information in real time just isn't feasible, and this is where server meshing comes into play. Think about the entire world of Ashes of Creation being a single realm. The realm makes up that world, but now we split up the world into many different pieces and we assign a server to each slice of that pie. As an example, the entire world could have 100 different servers that exist within it, and each of these servers are responsible for communicating game information from player inputs and outputs to world inputs and outputs to every player within the area of that slice of pie that the server is tasked to handle. But now that we have 100 different servers that make up a single realm, or in other words, the single world we are all playing the game in, we need a way to get those servers to talk to each other, because if we don't, then someone will effectively be stuck within their assigned server area. Server meshing, in its simplest form, is getting all of these servers to communicate with each other. This allows the game to be seamless for the player and enables us as individuals to make our way through the world and interact with other players in a seamless way. The way Ashes of Creation server meshing works is that we have the realm, or world, broken up into many different servers that are covering specific portions of the map. Each of these servers send and receive information to and from players, as well as to and from other servers. Each server that is adjacent to each other is passing information to each other. That way, when a player is going to a new zone and entering another server, the server they are coming from is handing off the information to the server they are entering to receive that incoming player. I want to take a moment to talk about the details of how the team at Intrepid does this and some of the cool tech they've implemented to ensure a smooth transition, as well as enable players to interact with other players who are on a different server. The real problem here is that when two players are on the edge of their servers and want to interact in some way, this could be a PvP battle or trading or communicating, this is where things get a little complicated, but I'll try to explain it as simply as possible. We have server A with player A, and we have server B with player B. Server A is passing information to server B about player A, and server B is passing information to server A about player B. The information that is being passed about the players between server A and B is not actually the full information about the players. Each of these servers is creating a proxy of their respective players. Think of a proxy as a duplicate of the player that has a portion of the player information. This could mean that the proxy or duplicate of the player has the movement and action information of the players but excludes other information. This is done to reduce the amount of information that needs to be passed between server A and server B, but still allows these two players to interact. So player A and player B can engage in a fight between each other across server A and server B. To further simplify, you have two servers with two players. Each server is creating a lightweight copy of the player within their server and sharing that information with the opposing server. This makes it easier for the two servers to communicate because they have to share less information than if it was a full version of the player being passed between both servers, which is also important for when one player crosses from server to server. If player A crosses into server B, server A and server B are effectively swapping information. Server A picks up the duplicate or proxy player from server B and then passes the full player information to server B. Since we know that servers that are adjacent are consistently communicating, it begs the question as to how the world or realm handles information that needs to be passed across servers that are not next to each other. This is where microservices come into play. Microservices are extremely important, and an easy way to think about what a microservice is that it is effectively an app. Think of WhatsApp, an app that enables people to send messages to each other. The app needs to store and share all the messages and information contained in those messages. With microservices and ashes of creation, they effectively have multiple microservices handling specific tasks and storing information related to that task. In other words, there are multiple apps running that are used to handle specific items such as guild chat, mail services, or player location. You could imagine this as a guild app, a mail app, and a player location app. These microservices run separately from the servers. You have your player and client, you have your servers, you have your realm that is made up of all of those servers, and then you have your microservices. All of these are individual pieces that are communicating. The player and client is only really communicating with the server, servers are communicating with other servers and all the different microservices. Not to overcomplicate things, but the information from servers and microservices are stored in a database so that information can be pulled and passed along as needed. This is what makes up our network architecture. All that network architecture really is, it is really the way that network devices and services are structured to connect all the clients, or in our case, our players. Again, with microservices, these are basically apps that are running in the background that are taking in information to then pass that information to the servers. They serve a very important role because they effectively reduce the amount of information the servers need to collect and share. This increases server performance and takes away any unnecessary processing. Let's jump into dynamic gridding, replication and replication graph, and relevancy checks. Then we'll go through all the crazy things Intrepid is doing that really makes everything associated with their network architecture so next generation. To fully understand dynamic gridding, we need to understand what replication and relevancy checks are because they are really the reason why dynamic gridding is necessary. You may notice a common theme here. A lot of the decisions, approach, and implementation of these things are done in a way to ensure that ashes of creation is optimized from a networking standpoint. There's a ton of information that needs to be transmitted in an MMO, and to do so without utilizing layering or sharding requires everything to run as quickly as possible. Oh, and for anyone that doesn't know, layering and sharding are effectively singular world servers, but the drawback is that layers and shards are used to split up player count to avoid having too many people on the same server and effectively within the same world. Replication ensures that the data on the client, or really the game you're playing as an individual, is accurate across the whole game for each player. That way, all players within the game have a consistent world state. Replication is basically just synchronizing all players' games to be identical to each other, and to do that, the server needs to replicate changes to the world across all players, or really all game clients. This directly feeds into relevancy checks because relevancy checks are telling the server what things need to be replicated, or more so, when they need to be replicated. This ensures that the server is not replicating unnecessary things for players, which overall is a way to reduce processing required per player from the server's standpoint. A relevancy check is basically the server's way of checking if a thing in the world is relevant and if it should use processing to recreate it for players. Relevancy checks and replication are ultimately what create the need for a replication graph. Imagine the replication graph as a grid that is laid on top of the world. This grid is basically telling the server what is eligible to be checked for relevancy. Just imagine if you checked everything in the world for relevancy 60 times per second. That's an insane number of things to check to see if it's worth loading and replicating. All the players, ores, trees, NPCs, and so on. The replication graph, or I'll say replication grid, allows the server to only look at the relevancy of things within a single square of the grid. So rather than checking the whole world to see if it is relevant, we're only looking at things within a portion of the world. This is a bit of an oversimplification because this grid is a lot smaller than just a quote big portion of the world, and there's quite a bit more going on here with how the server is deciding what to run a relevancy check on and in turn what to replicate. Now, dynamic gridding. Dynamic gridding is in many ways affected by replication, replication graph, and relevancy checks because all of these take up a lot of processing. And that can become too much when there are too many players in the same part of the world. When there are too many processes that need to be, well, processed, that creates lag in the world, and dynamic gridding is the way the team will combat the potential of that becoming an issue. Dynamic gridding is very much fueled by the server meshing tech we talked about earlier. All it really does is it allows the game to take a single server, imagine this square on the screen, and it can now break up that square into multiple servers to reduce how many players are on a single server. Because of server meshing, all of these players on these servers can still see each other and interact with each other, but it effectively is taking all of the information and splitting it across multiple different computers. Simply put, this means if we have hundreds of players in the same zone, they could be on multiple different servers, but because of server meshing, all these players can still interact. They are all still in the same world. To recap, relevancy checks are how the server decides what to replicate for players and to deem what is relevant to replicate. Replication is creating a source of truth for all players in the world and is effectively recreating world changes to pass along to players. Replication graph is a way for the server to better decide what to run relevancy checks on, and finally, dynamic gridding is a way for the servers to break themselves up into smaller servers within an area to support when too much activity is taking place in that area. Relevancy checks and replication take up a lot of processing and can be overwhelming when there are a large number of players congregated, and dynamic gridding ensures that the processing is broken up across multiple servers, or in other words, multiple computers to run those processes. Alright guys, this is where things may get a little too in-depth because we'll be talking in more detail about the implementation of a lot of these things and how the team has taken various steps to make these things work together and how they've optimized these to create a seamless game and world experience. It really is absolutely crazy how Intrepid has put all this together, and they've created a ton of proprietary systems to fuel the network architecture for Ashes of Creation. One thing that really stood out to me during their last update was how the network architecture team seems to be extremely diverse. They're utilizing technology from various types of network architectures. What I mean by that is that they are utilizing things you would see from blockchain networking, application networking, and so on. The systems they've created take inspiration from a lot of different types of networking that are not synonymous with gaming. I want to start with the thing that I literally lost my mind over: fault tolerance. But more specifically, why this is so crazy. Basically, fault tolerance is built by having multiple different servers running on a single realm. This means that if a single server goes down, the rest of the world can still run, and this is possible because each of these servers are able to replicate, whereas other large online games tend to have a single layer of replication. This also means that the team can run real-time updates and patches without bringing down the world. Now, for the thing that made me go nuts for this idea of fault tolerance comes directly from blockchain and something called Byzantine fault tolerance, also referred to as BFT. BFT is a consensus protocol that is used to verify information and ensure that there's a single source of truth across a network. Since we have loads of different servers working together to create this source of truth, it means if one server goes offline, the other servers can still create the source of truth in their designated area, and a single server outage would not affect the realm or world. BFT also serves as an alert system because any server communicating with a server that went down would quickly be alerted of the outage because there's no information being passed back. Along this same line, typical server meshing has multiple clients and servers, but these are all plugged into a single replication layer. That means if the replication layer breaks, the whole world goes down. Fault tolerance built into Ashes of Creation by utilizing multiple servers and dynamic server meshing means this is no longer a problem. Next, I want to talk about another insane development by the team, and that is creating multi-threading replication graphs in Unreal Engine. For background, Unreal Engine is considered a very single-threaded game engine. Think about your computer and your computer processor. If your processor has 16 cores, that means you can split your computing processes across 16 different cores. That's multi-threading. If you just use one of those cores to run all of your computation, that is single-threading. I'm actually somewhat familiar with this from working on a video game with a friend of mine, but what I did not know is that this is a problem that has not actually been solved from anyone else. That's right, Intrepid is the first studio to implement a solution into Unreal Engine to enable multi-threading replication, and it is entirely new. No one else has done this up until this point. If that's not innovation and next generation tech, then I don't know what is. This development was one of many that highly optimized the processing that is taking place on the replication side of Ashes of Creation. The spatial grid or replication graph update created a 1.5 times improvement to performance, roughly minus 35% to replication cost. Additionally, utilizing dormancy to remove rarely changed actors from the spatial grid, so things like trees, ores, destructible buildings, reduce replication time by another 80%. This equates to 7 times faster replication, and it still was not fast enough. This being due to worst case scenarios, high intensity PvP battles between hundreds of players. Lastly, Unreal Engine making replication multi-threaded led to a 2.4 times improvement to replication performance. All of these updates reduce replication time by 94%. That is absolutely massive. Again, why this is so important is because replication is a huge part of massive online games, and is probably the largest amount of processing being done server side, or in other words, being done by the server. Without optimizing replication, you would run into large lag spikes and rubber banding, especially if you have a significant number of players. The last thing I want to talk about is inter-server replication and dynamic server borders. As I brought up a little earlier, typically there is one replication layer that handles all replication across servers. In Ashes, from my understanding, each server has its own replication layer, and as such, inter-server replication exists. So effectively, each server can replicate things in the world. This is a major component that makes fault tolerance in Ashes and across a realm possible. Dynamic server borders are another great innovation because it enables servers to increase and reduce their server size based on server load. In other words, servers can change how big they are and adjust when too much processing is happening, typically due to too many players being in a single area. I hope you all enjoyed this video. Thanks so much for watching. If you did like it, go ahead and hit that thumbs up and subscribe. It really does help me out a lot. I do focus most of my content on Ashes of Creation, so if you're around for that, definitely subscribe. You don't want to miss out on the next video. Also, I will be streaming a couple times a week coming up very soon. I am hopping on some other people's streams in the coming weeks as well. So if you want to catch me live, there's a link below. I will be live on Twitch and YouTube, so don't miss out. Also, if you have any questions about all this techie stuff, leave a comment below. I'll try my best to answer. I'm not a software engineer, but I do have a little bit of background in product development, so I may be able to send you the right way at the very least. So thanks again, everyone. I'll see you next time. Moonman out.